Hello everyone, we're going to finish the 2018 3.4 exam today with the third question. So let's get started. First one, write an equation to represent the enthalpy of fusion. So this is, well, how kind are they? They even put melting here. So they're just asking you, how do we turn solid into liquid? And man, they even said melting. That's just giving it away. Now this is a very typical Merit-ish type of question. Why is the enthalpy of water always larger than the enthalpy of fusion? Fusion is melting, as they gave it away. Vaporization as a name, this is going from H2O liquid to gas. So the key thing is, compared to vaporization to fusion, is that you are completely breaking the intermolecular forces for vaporization, but for melting you are only partially breaking the intermolecular forces, hence you don't need as much energy. So it's always larger because much more heat energy to break all the attractive forces. When solid turns to liquid, you're only breaking some of it. Okay, nice and easy. Next one, so when I read this is a Q equals MC delta T sort of question. So 10.6 grams of ammonia, 6.65 moles of water, the mass of the final thing 75.6. So why is that important? Because if you add these two numbers together, that's 75.6. So that just tells you there's no change in volume. The temperature changes that, the constant is given, the molar mass is given. So let's start with some Q equals MC delta T. So what is the mass? Now this is the thing that people always get confused. The mass, this is the mass of the liquid, the mass of the water, the mass of the solution. It's given to you. The total mass is 75.6. It's not the chemical. It's kind of like saying, if I burn some petrol and then use that energy to heat up some water, the Q equals MC delta T measures how much energy have gone into the water. So you will need to measure the mass of the water, not the mass of the petrol, because you're not measuring the temperature change of the petrol, you're measuring the temperature change of the water. So this is the same thing here. You're measuring the temperature change of water caused by this ammonium chloride thing dissolving. Okay, so this mass is 75.6, C is 4.18, change in temperature, oops, should be multiplied. Change in temperature is the final temperature minus initial, so 11.5 minus 20.9. It's not always the bigger one minus the smaller one. It is the final one minus the initial one, and then thus you get negative 2970.5 joules. We don't like joules, we like kilojoules, so this will be 2.9705 kilojoules. I mean, this is not the final answer, so you can leave it here, or you can round to negative 2.98 kilojoules if you want, but you have to use the whole thing. Okay, now once we've done that, we need to find the next part, which is the enthalpy change equals negative Q divided by the mole. So how many moles we have? So this mole, this N thing, this mole thing is the petrol that we were referring to before. This is what is responsible for this energy change. What is the chemical that we're looking at? And this is your ammonium chloride. So that's 10.6 divided by 53.5. I mean, if you look at that molar mass, how would you figure out this molar mass? You need how would you use this molar mass? You need to obviously use the mass. So this is where you use that number. You only use each number once, really. So this is going to give you 0.198 mole, and then let's come back to here. So this will just be negative 2.97, so this will be positive. That will be positive 2.9705. Let's just write the whole thing in, divided by negative 0.198, and that's going to give you 15.0 kilojoules per mole. Very easy. Excellence free question, if you ask me. This is much easier compared to some of the other excellence questions you have to do for the standard. but just remember what the mass for each one is for. So the mass, this m in mc delta t, is to do with the water. It is to do with the total final solution's mass, not what you were given as the chemical, like not the petrol. Okay, just remember that. Next one. When I think this is the last one. Yeah, this is the last one. Yes, it is. All right. So when dissolving ammonium chloride in water is an endothermic reaction, but ammonium chloride readily dissolves in water. And they explain in terms of entropy change of the system and the surrounding and why ammonium chloride dissolves in water. Okay. So when we talk about spontaneity, we're looking at two factors. One is a negative change of enthalpy. One is a positive change of entropy. So if you have both factors, then the reaction is always going to be spontaneous. And now what do we have? We know we have a positive change of enthalpy, because that's what we've been given. It's right here, endothermic reaction. But then if you look at this reaction, this is clearly a positive change of entropy. Okay, I mean, this is so obvious. I mean, going from one solid to 2 moles of aqueous, that is going to be a positive change of entropy, because you have more moles of ions or aqueous particles, or whatever you want to say, produced from the solid, solids dissolving. So obviously this is an positive change of entropy, because it's more random, it's more disorder. So this particular change of entropy is looking at the system. So when we're looking at the system, this just means let's look at this reaction. Do I have a change of entropy? Do I have a positive change of entropy or negative change of entropy? So you just look at the products, look at the reactants. Which side is more random? In this case, the right hand side is more random. Therefore, you're going from less random to more random. You're going from less disorder to more disorder. Therefore, it's going to be a positive change of entropy in the system. Okay, let's look at the surrounding. So the surrounding is to do with the enthalpy. So this is a positive change of enthalpy. Positive change of enthalpy, which means an endothermic reaction. So this is an endothermic reaction, and from year 12 you to learn endothermic reaction, you are absorbing heat energy. Now, where is that energy being absorbed from? This is being absorbed from the surrounding environment. So if you have an endothermic reaction, that means it's sucking in energy from the surrounding environment. Therefore, the particles of the surrounding environment would have less heat energy. If they have less heat energy, they have less kinetic energy. Therefore, they don't move as random as they would. Therefore, there is a decrease in the surroundings entropy. Okay, so they absorb heat energy. So as a result, there's less movement or less randomness as a result, because they have less energy, and therefore they have, so the entropy would decrease. Okay, so the entropy of the surrounding decreases, the entropy of the system increases. And they're asking you in terms of why does it dissolve. So when it means it readily dissolves, that means the increase of the entropy in the system outweighs the decrease of entropy in the surrounding. I mean, that's just simple way of putting it. Or you can say the total entropy change is positive, because you just have to consider, you're just looking at these two, which one is more significant. And they even told you it readily dissolves. Where is it? It readily dissolves. Readily dissolves means this is a spontaneous reaction. So they're telling you it's a spontaneous reaction. So you just need to say this increasing in entropy in the system outweighs the decreasing entropy in the surrounding. Okay, and I just want to do this a little bit more because people always find the entropy stuff a little bit difficult. if you think about these two, the two conditions for a positive change for a spontaneous reaction, I think we spent enough time on the positive change of entropy. Why does a negative change of enthalpy result in a spontaneous reaction? So this it leads to the entropy of the surrounding, doesn't it? Because if you have an exothermic reaction, you release heat energy. Where does that energy go to? Go to the surrounding environment. And what does that mean? The energy goes into the particles. They are more energetic, they move around more, and they're more random. Therefore, the entropy of the system, the entropy of the unit of the surrounding would increase. Okay, so you have entropy of the surrounding increases if you have the entropy of the system increases, and that means you would have a spontaneous reaction, because that's what the fundamental concept of entropy is. That's how the more random something is, the more stable they are, the less energies they have, and that's more stable in that regard, and that's more spontaneous that way. So yeah, so let's have a look at the answers. So when the ammonium chloride dissolves in water, entropy increases. I mean, more moles of particles, that's pretty straightforward from the equation. More disorder, Since the process is endothermic, that means the decreases of the surrounding environment because the heat energy has been transferred, and the decreased random motion because there's less energy, because it readily dissolves in water, it must occur spontaneously. That means the total entropy is positive, or you can say the entropy of the system outweighs, or you can say it's more significant compared to the decrease of entropy in the surroundings. Okay, so the entropy equations, you just need to get your head around it. Unfortunately, just always think about you can, like some teachers I know uses the Gibbs free energy to teach it. That's not really part of the syllabus. It won't get you anything if you use it. You can't just say, oh, the G is negative, therefore it's a spontaneous reaction. Yeah, what does the G even mean? Do you even know what it means? It's actually a really complex equation. And then temperature always comes in play as well, because when you have a higher temperature, lower temperature, higher temperature involved. If you think about a higher temperature, you obviously maximize the change of entropy, because higher temperature means more heat means more randomness, so on and so forth. Okay, but this is pretty much covers everything you need to know in terms of the entropy side of things. So yeah, and if you do have any questions, leave it in the comment section. I do check my comments very frequently, and that will be that'll be all. I believe that's all the 2018 exams done for level 3. So yeah, hopefully you've been finding these videos helpful, and like always, smash the like button, subscribe if you haven't, and I'll see you guys next time. Bye bye.